For the purpose of doing regression analysis, I chose the data set from Kaggle. This data set is of diamonds and prices of diamonds. So the data set contains price in US dollars, carat of each diamond, cut quality, which is either fair, good, very good, premium, ideal, color ranging from J to D, J being the worst and D being the best, clarity, 7 different classes, length of the diamond, width of the diamond, and percentage depth of the diamond with total depth percentage, along with table, which is the width of the top of the diamond. Now this is the dataset. It has about 54,000 records. So as you can see, we have 3 categorical variable: cut, color, and clarity, and all the other variables, carat, depth, table, price, X, Y, Z, are continuous quantitative variable. Now price is the dependent variable, and all the other variables are independent variables. Now to analyze this data set, crosstab is not the type of analysis you want to do here, because crosstabs limits 1,000 records and we have 54,000 records. We can do a sample of the data set and do a little bit of crosstabs, but again we're cross-tabbing against price. Instead I'm gonna do frequency. So frequency for the categorical variables, statistics, mean, sum, skewness, kurtosis, and bar charts. So this gives us a frequency of the categorical variables. As you can see, we have ideal cut is the most number of cut in the diamond among the different colors. G, which is fairly in the middle, has the most number of color in the diamonds, and for clarity, if you look at percentage, 24%, that is the highest, SI1. Now I1 is the worst and IF is the best clarity. Then it's I1, SI2, SI1, VS2, VS1, VVS2, VVS1, and then IF. I'll add this scale, all these scales, in my analysis for reference. So bar chart, fairly normal. This does have some, it looks nearly normal, and this is a bimodal, but since we have 54,000 records, I think in our analysis it won't be that big of an issue. Now we also want to analyze our quantitative variables, so you can do descriptive analysis, each of them. Mostly we want to see the price. What's the average price? And option, you want to see the mean, distribution, skewness. So we have the descriptive statistics for our quantitative variables. So now mean price, minimum price $326 for our diamond, and maximum is $18,800. Mean is about $4,000, and fairly high standard deviation of $4,000 since our range is so high. Now, further analysis on skewness and kurtosis I'll add with my analysis of the entire process in our discussion. So now let's move on to regression. So price is our output variable, so the dependent variable, and we want to see how each of these change, how each of these affect the price. Since cut, color, and clarity are categorical, what I've done is I've cleaned them, I've transformed them into nominal scales. So I've added weights based on the information provided on the dataset in the website Kaggle on what is best and what is worst. So I've added one for the worst, and based on the number of categories in each variable, I've added one additional weight. So for the cut, I have 1 to 5, for the color 1 to 7, and for the clarity 1 to 8. And now you wanna do regression analysis. So it's linear regressions because price is not categorical, it is not binary, it is a continuous variable. So price dependent, and we want to see, now it is necessary to encode them into quantitative so that we can check their effects on price, because even without having the domain knowledge, you can tell that color, clarity, and cut, they would have a lot of effect on price, and we don't want to discard them. We want to see how they actually affect the price. So in a regression, you need quantitative variables. You cannot do regression with qualitative variables, sorry, categorical variables. So for statistics, we want to see estimates, quantity. We also want to see R-square change, model fit. This is good. We want predicted and residual. We want to see the histogram and normal probability plots. And for the options, it's good. We want unstandardized, standardized, predicted values, and let's just see standardized residuals just for our analysis. Why not? Let's take standardized residuals as well, just to see how our model fits. Everything else is okay. Continue. Okay. So results for the regression are out. We can see the R-square value is 913, sorry, 83%, which is fairly high. That might be due to overfitting, or maybe our model is actually really good. Though I doubt just a simple linear model is good enough for this kind of a data set, but we do see that we have 83% R-square value, which is fairly good. Looking at the beta coefficients and their significance, so we chose 95% confidence interval, so our confidence significance level is 0.05. So all the beta are positive. You see that Z, which is the depth, it's not significant. Table is also not significant. Table is the top width, the top part compared to the point, like lower point of the diamond. It's not significant too on price. So from beta we can see that cut, color, clarity very significant. Clarity has a higher beta, and length has a high beta. Depth is okay too. So only width and width is good. Only Z depth and table are not significant. We also want to take a look at the charts. It's still processing. So histogram of the variable price, fairly normal, perfectly normal. If we look at the fit of the model, it's not a bad fit. There's some variation here, but overall fit looks good. And this is the residual scatter plot.